So, dear students, on the behalf of the Department of Metallurgical Engineering and the Indian Institute of Technology, Banaras Hindu University, I would like to welcome you to the new course, that is the transport phenomena. So far as the importance of this subject is concerned, it is of immense importance so far as the control of the various metallurgical processes are concerned, ranging from the extraction of metal either through the blast furnace route, extraction of copper through the reverberatory furnace route, extraction of mercury, processing of metals and alloys through different processings of solidification. All these things can be governed and controlled with a high precision if you have a good understanding of the transport phenomena and the modeling of those metallurgical processes. So, basically this transport phenomena, this subject has three main portions. The portions are it basically consisting of three major portions. The first portion is the dimensional analysis, and momentum transfer, This is the first portion. The second portion is your heat transfer, and the third portion is mass transfer, and a small chapter is associated with the mass transfer is simultaneous. When you go through all the transfer processes, simultaneous transport of heat, mass and momentum, heat, mass and momentum. So far as the syllabus of the subject matter of study for this subject is concerned, you can easily see on the courses of study that is available on the website. So, you can easily take from there. So far as the different books are concerned, I would like to mention some of the book which is useful for a particular section. So far as the dimensional analysis and the momentum transfer is concerned, in my opinion, the best book in this direction is for covering of this chapter is book by C.J. Gyankoplis, either you should go for this book, or book by J.R. Welty, or book by R.B. Bird. So far as this heat transfer is concerned, you should go the book written by S.K. Som, Professor Mechanical Engineering at IIT Kharagpur, heat transfer by S.K. Som. You can also go through the book the transport phenomena in materials rate phenomena in materials processing by A.K. Mohanty. This book is basically written on the metallurgical guidelines, and you will find the analysis of different metallurgical processes pertaining to the metallurgical engineering in this book. Another very good book on all these three aspects and their consequent application in metallurgical engineering in the book written by Jackley and Themelis. The name of the book is Rate Phenomena in Metallurgy. That is an excellent book which covers the utilization of the heat, mass and momentum transfer in different metallurgical processes. You will get a clear cut concept of all those the utility of all those transport phenomena in the metallurgical industries. This is an excellent book for doing such type of businesses. So far as this mass transfer is concerned, another book is regarding the heat transfer is the heat transfer by J.P. Holman. This is a book published by McGraw-Hill. This is also an excellent book. So far as this mass transfer is concerned, you must go through the book by Gyan Koplis. And R.B. Bird. At last, I would like to elucidate that why the various textbooks written by the foreign authors as well as the Indian authors, why they put up a special emphasis on the simultaneous heat and mass transfer. The very reason behind that if in a nutshell, within a few words, if I would like to explain the things, that why there is a necessity to discuss the heat momentum and mass transfer in a simultaneous manner. So, why it is necessary, that I would like to make you understand through a table. Let us suppose in first column of the table I am putting the name of those quantities which is getting transported. In the second column, I will give stress on the basic equation which stands responsible for the transfer of that particular quantity, and in the last, which type of phenomena is going on in that particular transport phenomena. Let us suppose I am talking about the momentum. Momentum is the quantity which is being transported. The fundamental equation regarding the momentum transfer is the Newton's law of viscosity. This is given by tau is equal to minus mu into rho. Mu is the dynamic viscosity, rho is the density into the velocity gradient dV upon dx. The phenomena which stands responsible for control of such type of transport is the viscosity. Second one is the heat energy. Heat energy, the equation which stands responsible for provide an interpretation for the heat energy transfer is the Fourier law of heat conduction. The equation is Q upon A, that is the flux divided by cross sectional area through which that particular amount of heat energy is being transmitted, that is equal to minus K into the velocity into the temperature gradient K. Q by A is equal to minus K dt by dx. This is called the heat conduction phenomena. Another is the mass, the quantity which is transported is the mass. The basic equation which stands responsible for explaining such type of thing is the Fick's law of diffusion, written as J is equal to minus d into dc by dx. This is called the molecular diffusion. Because of the fact that you can easily see that if I am talking about the momentum transport, the very principal quantity which stands responsible for the description of momentum is what is velocity. So, the velocity gradient is considered here. Heat energy, that means heat cannot be transported from one place to other until there is some temperature difference, or in other words, in engineering sense, we can say that unless and until there will be gradient, that there should not be any transfer of heat energy. So, the quantity temperature gradient is utilized. You take the small volume of any perfume and keep it open at the one end of the room, and after some time it will get dissipated to every corner of the room. Why it is so? Because of the fact the concentration of that particular perfume in one of the corner is maximum, whereas if the concentration of the same perfume in other parts of the room is almost 0, then from a higher concentration to lower concentration the mass will flow. That means, in the case of mass transport, we consider the concentration gradient, that is dC by dx. So, a molecular diffusion case can happen. So, in all these three equations you can see that the temperature gradient or the velocity gradient or concentration gradients are there. So, the scientists and technologists were thinking on the issue that why not there should be any correlationship that should be derived between all these transport processes, so that when and where it is necessary to go through the simultaneous transport of all these three aforesaid quantities, these things can be interrelated, and this gives rise to the concept of development of different analogies between mass, momentum and heat transfer. Now, I would like to put up some emphasis as an introductory class that what are the different analogies which are available in the simultaneous heat and mass transfer. The very first and foremost analogy is called the Reynolds analogy. So, in a tabular form, name of analogy and the associated transport with that analogy, associated transport. First is the Reynolds analogy. Reynolds analogy. The associated transport is heat and momentum in first Reynolds analogy. Another analogy has been developed also, where there is analogy between mass and momentum transfer. The next one is the Prandtl analogy. Prandtl analogy, one Prandtl analogy is between the heat and momentum, and on the similar guideline as the Reynolds analogy have, the mass and momentum transfer can be put up in the same analogy by the Prandtl hypothesis, the Prandtl analogy. And the third one is the Chilton-Colburn analogy. Chilton-Colburn analogy. This is an analogy which stands responsible for the associated transport of heat, mass and momentum at the same time. Heat, mass and momentum. So far as the nature of this paper is concerned, this is very much interesting and mathematical paper, where you can obtain a very good marks subject to the condition that you have given the enough stress or enough emphasis, or you have taken the enough interest in order to understand this paper. So far as the distribution of the marks in the exam is concerned, if this pandemic ends and if you are coming to the college, then for the 20 marks there will be mid semester examination, for the 60 marks there will be end semester examination, and the rest 20 marks will depend upon your appearance, your capability to interact with the myself, and your capability to answer some of the questions posed by me in the classes to come. So far as the distribution of the marks with reference to a particular question is concerned, For 10 marks question, the 4 marks will be related with the theory part or direct application part, and the next 6 marks will be related with the application of that theory part into the numerical problem that may contain a design related problem also, simple design related problems. So, this is all about this your course, that is the TP, transport phenomena. The subject code is perhaps MO102. Thank you. From the next class, we will start the dimensional analysis. Once the dimensional analysis will over, after that we will go to the momentum transfer, after that heat transfer, and then mass transfer. So, this is the introduction to this subject in a nutshell. Thank you.